Okay. State whether or not the function satisfies the hypothesis of the mean value theorem on the given interval, and if it does, find each value of c in the interval a to b that satisfies the equation. What is going on?
Hey, who's they? I didn't say that.
Who? They.
Well, no, they.
Okay. Number 2. F of x is equal to x to the 2/3 on 0 to 1. Closed interval.
What was the directions again? I heard it, but like I didn't process it.
Part A, state whether or not the function satisfies the hypothesis of the mean value theorem on the given interval. And then part B, if it does, find each value for c in the interval a to b that satisfies the equation.
Okay, let's see if I can figure out what this means. I like how it's like multiple pictures. It sends me like one long picture.
Sometimes it does and sometimes it doesn't. I don't really understand, like,
Kind of funny. I like it.
it's reasoning, but it just happens.
And then every point of the picture.
All right, so the mean value theorem, just as a refresher, and it's kind of written in there, like, in the instructions, they rewrite the mean value theorem for you. So basically to say that it does satisfy the hypothesis. F prime of c, so whatever c is equal to f of b minus f of a all over b minus a. There was really cold air coming out. I was seeing if it was warming up at all.
Is it?
Maybe. I don't feel it as much anymore, so maybe.
Crank it all the way.
No, it's okay. I'm not cold anymore. I was really cold initially. That's why I was just like...
It's always cold in the module.
So my dad said yesterday that it was like just blowing air. Like it wasn't like AC or heat. And that's why I was so cold. Because like sitting right here, it just blows out. Just like I can just feel it. Because like the vents go this direction. And I was like sitting there and then people were over there in their desks like shivering. And I was like, Dad, can you please do something about this? Because I had that thing all the way as far around like as it went. And he was like, I fixed it. He had to like turn up the temperature so it would stop blowing out cold air.
How did you fix it?
He went on the computer and changed the temperature for yesterday because it was too cold or it was too warm outside for the heat to be on. Anyways. Okay. So what we're going to do, f prime of c, we're going to take the derivative of this, okay? And where we have x, we're going to put a c because it's going to be some number and we don't know what that is. Okay, so take the derivative but replace x's with c. So what is the derivative of this?
2/3 x. Negative 1/3.
Okay. So that's the derivative of x. So with respect to c, we're going to have 2/3 c to the negative 1/3 is equal to, so we've evaluated the derivative at c. That's what's happened so far. Is equal to, now we're going to plug this stuff in. So this is a, this is b. So f of b, so that's 1 to the 2/3 is just 1, minus f of 0, or yeah, so then 0, what is going on? 0 to the 2/3, which is going to be 0 over b minus a, so 1 minus 0. So that says that 2/3 c to the negative 1/3 is equal to 1. So then multiply by 3/2 to both sides. So we have c to the negative 1/3 is equal to 3/2. Now, realistically, what does this mean on this side? Josh says this. 1 over the cube root of c is equal to 3/2. So if I cube both sides, I get 1 over c is equal to 27 over 8. And then I flip it, so I get c is equal to 8 over 27.
And that was just A.
No, that was both.
Oh. What was the question? What was B?
Part A is this initial step down to like
Oh.
here where we say that it was equal to 1.
Oh.
And then this is part B of actually finding
I
C.
was a little worried because I
You
was
were
like,
like,
is
that's a
that
lot
multi
for...
or- yeah.
Um,
Yeah, that was
all right, for f of x is equal to the absolute value of x minus 1 on the interval 0 to 4. All right, what do we know about this function?
It has to be positive, absolute value.
Okay, it has to be positive. It's an absolute value. What's the graph look like? What does
Parabola.
this
Yes,
cause?
it's like
Oh,
the-
cusp. Wait,
It's like
origin.
it's the-
Oh.
Alright.
I knew it was that. I just don't know what.
A breakpoint.
What is that?
What is what?
What are you even pointing at?
What are you pointing at?
Something that looks like this. What is this?
A hinge.
Oh my goodness.
Corner.
What am I looking
Yes. I was like, what is this?
Oh, corner.
I didn't know that's what you were pointing at.
That is not where I was gonna go.
I was like,
Oh.
that's a calendar.
A corner.
You
What's
should've
the
just
problem
pointed
with
to
the
it.
corner?
It's not continuous.
Okay.
The problem with the corner is that there's a critical.
Is there going to be a derivative there?
No.
So we say
Wow, that was aggressive.
no. There is a corner.
We just say no to the problem.
Now, which way is this graph shifted?
Left.
One.
It's inside.
Oh, so it shifted right.
Right one.
Oh.
So there's a corner at x equals 1. Because we can't take the derivative of an absolute value.
Oh, that makes sense.
That does make a lot of sense.
I was about to question it.
Mm-hmm.
That's why. So we couldn't have done this because of that reason. We could have done the right side, but we couldn't do, if that makes sense. Like we couldn't take the derivative for the left side part.
Yeah.
6. F of x is equal to the ln of x minus 1 on the interval 2 to 4.
We can take the derivative of this.
I forgot.
Isn't that
The derivative of the line is 1 over x.
So this one would actually be what?
1 over x minus 1.
1 over x minus 1. And it would be a chain rule, but the chain rule part would just make it 1, so just that. So replacing it with c, we get 1 over c minus 1 is equal to f of b. So it's going to be the ln of 4 minus 1 to the ln of 3 minus the ln of 2 minus 1 to the ln of 1 over 4 minus 2. What is the ln of 1?
0.
0. That part goes away. So I'll have 1 over c minus 1 is equal to the ln of 3 over 2.
You just a calculator too.
It will be. So then we can flip both of these fractions so that we get the c part on top. So we'll have c minus 1 is equal to 2 over the ln of 3. And then add 1 over. So c is equal to 2 divided by the ln of 3 plus 1. And somebody can tell me what that equals. So again, this was part A, and then part B starts here. All right, are we okay on mean value theorem? Pretty chill. All right, let's see. Word problem. What? Did you say no thank you? All right, 12. This one is about temperature change. It took 20 seconds for the temperature to rise from 0 degrees Fahrenheit to 212 degrees Fahrenheit when a thermometer was taken from a freezer and placed in boiling water. Okay, explain why at some moment in that interval the mercury was rising at exactly 10.6 degrees Fahrenheit per second. Okay, so y'all know we're talking about like a little mercury thermometer, like the giant one that Miss Patton has on her thing for money. Anyways, you know what I'm talking about.
Yes.
Okay,
Yes.
so basically they took that out of the freezer, they put it in the boiling water, and it took 20 seconds to get from 0 to 212. Okay, so based on that, at some point there has to be a time when it is rising at 10.6 degrees per second. Okay, so some things that we know, it's going from 0 degrees to 212 degrees in 20 seconds. And so they want us to show that at some point it's rising at 10.6 degrees Fahrenheit per second. So start you with a little graph to help you visualize it. So down here I'm going to have 0 to 20 seconds. Over here I'm going to have 0 degrees to 212 degrees. And so the initial is 0 degrees at 0 seconds. And the final is at 20 seconds, it is 212 degrees. Now, is there a straight line path from 0 to 20? Or I mean, like 0 up to 212, like degrees.
Like connect the dots.
Okay. maybe that was a bad question.
I mean, it's possible.
Would it go at a uniform pace the whole time?
No.
No.
No,
So
I feel like it would be like a little faster at the beginning.
it's probably a little more rounded. Okay, maybe not exactly that, but it's probably a little more rounded in how it's going. It might take a little bit for it to start to get up, and then all of a sudden it's just going to jump up to 212 degrees. Okay, so normally we would think, oh, it'll happen in a straight line, but that's not necessarily what happens. So,
I think you draw it as a straight line.
huh?
I said, I was just like, yeah, draw it as a straight line.
Yeah, I was like, that was a poorly worded question. All right, so this rising at 10.6 degrees Fahrenheit per second is going to be our f prime of c.
Okay.
Okay, so this is equal to f prime of c. So my f of b minus f of a over b minus a. So f of b, okay, is 212, okay, because at 20 seconds, it is 212 degrees, so that's where that's coming from. So it's going to be 212 minus, at time interval 0, it's 0 degrees, so minus 0, over, it takes 20 seconds to happen, so 20 minus 0. And we say that this is going to be equal to 10.6. And I'm not putting units on, but obviously I could. And so, by the mean value theorem, because I can write it like I just did, by the mean value theorem, at some point, it had to be rising by exactly 10.6 degrees Fahrenheit per second.
Oh, so we were just like proving that at a point.
Basically, yeah. Example 4 on page 202, if you want to just like look at that, also shows this as another example, so you have something else to look at if you want to see that. All right, next thing. Use analytic methods to find the local extrema, the intervals on which the function is increasing, and the intervals on which it is decreasing. So we're going to find either a max, a min, or both, depending on the problem. And then we're going to talk about the intervals that it's increasing and decreasing based on what value we have. So, 16g of x is equal to x squared minus x minus 12. So what's my first step to find min or max? Just take the derivative. So g prime of x is equal to
2x minus 1.
then what?
Second. Oh, equal.
Okay. I'll go ahead and find the second derivative and then I'll keep going. So what's the second derivative?
2.
Just 2. Okay, so I need to find what now?
When x is 2 equals 0.
Okay, so 2x minus 1 equals 0. So x equals 1/2. Now what?
You
Pop that into
plug it
the
back in.
first question.
Plug that back into the original.
Hearing some mixed things here.
The mix.
Don't you plug it in?
I am gonna plug it in. What is that gonna tell me?
Tell you
Your
Fifth and then
critical
the
point.
second derivative is
Right now, what is this?
the critical point.
A critical point.
Yeah, that's the point.
Okay. Now, I've already found my second derivative, and it is
2.
okay. So what am I gonna do?
Plug them both into
Hmm.
plug them both into the
I don't need to plug them both in. I first of all want to know, is this value going to be a min or a max? Using the second derivative test, what is this?
back to that.
I'd have to go back.
Second derivative is greater than 0.
Oh. Then it's a min,
So it's
right?
min.
That's a min. Okay, it's opposite of what you would think. So there is a min at x equals 1/2. Okay? Now, when y'all are telling me to plug it back in, what is that going to find for me?
The max. No.
In
We would say there is a min of blank at
it's finding your
Other
point. Your-
not a critical point. I'm finding the point itself, okay, where that min is actually occurring. Okay, so I'm going to plug this back in. So g of 1/2, 1/2 squared minus 1/2 minus 12. So this is 1/4 minus, I'm going to convert this to 2/4 minus, I'm going to make this something over 48/4. So that means negative 49/4. So part A says find the local extrema. So using all this lovely math that I've done, there is a min at the point 1/2 and negative 49/4. Okay, so remember, some of the problems in the last section just asked you what the min value was. Some of them were asking you for the point. Okay, in this section, they want the point given. Okay. Now, it says to find the intervals on which the function is increasing and decreasing. So B is increasing, C is decreasing. And I want to know where that is happening. So, knowing that that point is a min, what must be true? What must my interval for increasing be?
It's gotta start with that.
It's got to start with that. What do you mean? Tell me what the interval would be.
If f of x1 is less than f of x2, it would increase.
So f of 1/2 is. Wait, never mind.
Well, we know that we know that this is what shape? What kind of graph is this? A parabola facing which way? Okay, it's opening up. It looks like this. Okay. So, if this point right here is a min, what must be true? Okay? So from here to here, for y'all, is increasing, right? From here to here, it would be decreasing. Are you tracking? Do we know what increasing and decreasing means?
Ain't that the interval split?
Huh?
Ain't that the interval split?
Yes, that's what I'm asking for the interval. So it's increasing from 1/2 to infinity, and it's decreasing from negative infinity to 1/2. Okay, so the min and max values are telling you where it's turning around. Trying to decide on another one. Um, all right, let's look at 22. I was trying to find y equals x to the 4th minus 10x squared plus 9.
Okay, so this is the same as the last problem.
Yeah, same instructions. So we need to find mins and maxes, and then increasing and decreasing. So y prime is
4x cubed minus 20x.
Are you gonna go ahead and do the second derivative?
Yeah, sure.
All right, second derivative then is
4x squared minus 20.
We set the derivative equal to 0. Whatever.
all right. Back to algebra.
Okay, so like
You can take out 4x.
So 4x, which will leave me with x squared minus 5.
so divide by 4. Or divide by 4.
How about set both pieces equal to 0?
I guess you could do
So 4x equals 0, and then x squared minus 5 equals 0. So x equals 0.
And then x equals the square root of 5.
Or
Or just plus or minus.
x equals plus or minus the square root of 5. So what does that mean? I have what? How many mins and maxes?
1, 2,
3. 3.
oh.
Okay, it's more than we've been having. So now I'll go back and figure out what points they are later. I want to determine if they are mins or maxes, though. How do I do that with my second derivative test?
Set the second derivative equal 0.
so pop back and verify for where is it? Get there eventually. Somewhere down here.
Oh no, you have to plug in. The thing into the second derivative, and if it's above 0 or less than 0.
If it's equal to 0, then we have to go through and do all those lovely things, but hopefully it's not. All right, so I'm going to do the second derivative evaluated at 0 first. That's equal to negative 20. So that means that this is going to be a max. So I'm just going to put a little note beside them initially. I'm going to write these as two separate ones, just so I can write beside them. So positive square root of 5, so 12 times the square root of 5 squared minus 20. So that's going to be 12 times 5, 60 minus 20, so that's positive 40. So that means that's a min. And at minus the square root of 5 squared, that is also going to be 40, so that one is also a min. Now I need to evaluate by putting these in up here and getting their actual points. So for part A, we have a max at the point 0, and if we plug in 0, we get 9. Then for our mins, we have a min at minus the square root of 5, and I might actually need to put that one up here so I can. So minus the square root of 5 to the 4th minus 10 times the negative square root of 5 squared plus 9. So that's going to be 25
84.
minus what?
Wait, don't leave me nothing there.
That should be 25 minus 50 plus 9. That's negative 16.
Yes.
Now, because everything is squared, so everything became positive, what must also be the case?
It's the same.
It's going to be the same. So now, I need to think about where these points are occurring, right? I really don't have them in order. Okay, the negative square root of 5 and negative 16, and then it should be 0, 9, then it should be 5, the square root of 5, negative 16, right? See that in order on the graph. That's how they should be. This should really be point 1, 2, 3. So when I'm looking at increasing and decreasing, okay, I care about that. So part B was increasing, and then C is decreasing. So from negative infinity to negative 5, what's happening?
It's increasing.
No, it's decreasing. Wait. Oh yeah, it's increasing. I don't know why.
Negative infinity to negative 5. So if there is a min, and my first min is at negative square root of 5, that means that the graph had to have been coming from where? A min would look like this. So the graph had to be coming from where? So
So
decreasing.
So what are we saying?
Y'all said it was increasing.
Oh, I thought you were
It's
putting- I thought
decreasing.
you were trying to put it on.
No, I was asking which one, where they go.
Oh, I thought you were already
I'm gonna put
saying
them
it was
on in
already
order.
increasing.
So, negative infinity to negative square root of 5. And we include that. Now, on the other side of that point, so between negative square root of 5 and 0, what's happening? Increasing. So from negative, negative square root of 5 to 0. Sorry, it's supposed to be including. I don't know why I did that. Why is it yellow? Okay. From negative 5 to 0, it is increasing. Now, between 0 and square root of 5, what's happening? It's going from a max to a min, so it's decreasing. So from 0 to square root of 5, it is decreasing. And then from square root of 5 to infinity, it's going from a min to, we don't know, so it must be increasing. Oh, not negative square root of 5, just square root of 5 to infinity. All right, let's look at antiderivatives. So when we do antiderivatives, what did we say yesterday that every single one must have?
Plus C.
Plus C, why?
Because we don't know if there was a constant.
We don't know if there was a constant that had been removed. So this says find all possible functions f with the given derivative. So when that's saying basically like don't forget to add the plus C part because that could be any function. So the derivative, so f prime of x is equal to 2. So I'm trying to find the antiderivative. So f of x would be equal to 2x
Plus C.
plus C.
That's the last thing she said. Now I forgot.
Don't forget the plus C. Okay, now remember, if you take the derivative of this back, the C goes away. And then this becomes 2, so you can always check and make sure that you did your antiderivative correct. All right, we're going to get a little crazy. F prime of x is equal to sine of x.
Oh my goodness, that's insane.
So, what trig function has a derivative of sine of x? You may need to put a sign of some sort in front of it.
It is
Oh.
negative cosine x
Oh,
plus
okay.
C.
Okay, yeah.
Okay,
So,
that's
in
what
general,
tripped me up.
Yeah, so in general, the derivative of cosine is
Negative sine.
negative sine, but because it's positive, I need to put the negative in front.
I was like, wait,
It's like, wait a minute.
Yeah, I was like, they're probably going to be like, what do you mean? There needs to be a sign change. But that's why, like, if you forgot about that, when you took the derivative of cosine of x, you would have been like, oh, that's minus sine of x, something's wrong, and then you would have just known to throw a negative out front of it.
Or would have just thought the derivative of cosine of x was sine x.
Or you would have just been confused altogether. But, all right,
Which might have been where we were heading.
f prime of x, getting a little crazier,
Oh, geez.
is equal to 1 over x minus 1.
Oh.
X is greater than 1. That's relevant because we're trying to find the original function. So f of x would be what would give you the derivative that looks like this?
I mean,
What function?
ln of x minus 1.
Okay, there you go. You got it. Okay.
Alright.
So 1 over x blah 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 is going to be some form of a logarithmic derivative. And so this one obviously is an easier one. They're not going to give you anything that requires a chain rule per se. At this point, you don't know enough information yet. So ln of x minus 1
The only reason, plus c.
plus c.
Gosh, I'm getting-
I'm telling you, that's the thing that people miss the most is that plus c part.
Stop. The only reason I knew that is because it wasn't like the first problem we did or something. Second.
So it's working backwards now.
Like, why do they want to do that?
All right, so your problems 1, 3, 11, 15, 19, 29, 31, and 33. And I won't make them due till Friday. But tomorrow we will be doing 5.3, looking at graphing the derivative and second derivative functions to an extent. So we'll have some notes and then some continuation of some of those notes we were doing the other day where I was like, this part we don't need yet, so we didn't finish all of them. Yeah, concavity will be a big one. So we'll pick up with that tomorrow.